There are eggs in there, yeah. Okay, so
How do you know how much you're getting there?
we don't. We're just doing a preliminary test here, but eventually we'll want to quantify that.
You can reduce the brightness if you want.
Yeah, let's do that. That's good.
That's good.
Yeah, do you want to quick look at the chair?
Still going. Wow, that worked well. So you can see that the water is actually running out of the slime there. So it's a very loose aggregation of these fibers in the water and the mucus component. Yeah, that's a good way to see the fibrous component.
So imagine getting this on your gills.
Is the light catching the fiber there, or do you want to?
Yeah, it is.
It's pretty cool.
So basically in here I've got some slime that was extracted from the hagfish, and it's in a buffered solution, of course. And what I'm going to do from that is take just a few of the footballs that are basically wound out fiber and try and grab one of these with two tweezers and mount it on my little apparatus, sort of open it all up, make tiny little knots in there, and then mount it on my mechanical testing apparatus and do some mechanical testing on it. Okay, so in here I have a tiny little square of glass with a very minute glass rod pointing up vertically, and all around there's probably about 200-300 tiny footballs. Each one is 1/10 of a millimeter in length. And I'm going to wait for them to just open up a bit, and then I'm going to grab on them with my very fine tweezers and mount them between my two glass rods. There you go. Cooking. Oh, you got potential. So they're right next to it right now.
Can you run your tweezer down the length of it? Well, you know, I'm getting a weird reflection after.
All right. That's the glue drop that I just glued the fiber with.
Let's get our feet into what we're looking at.
Yeah, so right now what we're looking at is one of the fibers that I showed you that I was mounting. I basically mounted it on a vertical glass rod that now is going to act as my force transducer. It's going to show me how much force and how much tension the fiber can basically take, how much energy it can absorb. And have here, it's called a video dimension analyzer, which basically is just a small rod of light that's the light I'm moving right now, and it will follow the movement of the glass rod as I operate it. And because I know the length of the glass rod, and because I know the diameter of the glass rod and the type of glass, then I know exactly how much force it takes to deflect that glass rod, so I can go back and calculate all the physics of it and find out basically all the properties I'm interested in. So what I'm going to do is just gonna...
We're gonna do batteries. Oh, hang on, stop.
No, I'm not, don't worry, I'm not. I have the fiber with the glue drop, and as I'm going to start pulling, it's going to start pulling onto the glass rod to a point where it breaks. So I'm just going to start the motor, and it's going to start pulling the glass rod. And because it's an untreated fiber, it will probably pull it right out of the screen. Actually, maybe not. It's a pretty thick glass rod. There you go, we lost it. So it broke. So it's amazing when you think about this tiny little fiber, 1 micrometer, pulling on this giant over 200 micrometer glass rod, and just being able to deflect it, and you saw how much of a deflection you got without like any problem. It's just incredible.
So what do you